Okay, here are the questions that I received that I wanted to address. So the first one is, can E and ln cancel each other out? Can they always cancel each other out, or is there certain situations they cannot? So that's kind of a tricky question because E and ln generally do cancel each other out, and I just want to show those circumstances again where that happens. Maybe you have e to the x equals 7. Now I want to cancel that e out, and so what I'm going to do is I'm going to take the ln, the natural log of both sides. So then you have natural log of e to the x, you have natural log of 7. The natural log and e are going to cancel each other's self out in this situation, and we're left with x equals the ln of 7. Okay, and that's the situation where we use the natural log to cancel out e. Now the other situation is sometimes we have like the natural log of x equals 4. Now what I do to get rid of the natural log here is I have to do e raised to the natural log of x equals e to the 4. And then again, we're going to see that canceling out. Okay? And this would end up being x equals e to the 4th. Now, some situations that, the one situation I can think of that they won't cancel each other out would be if you just had like e times the ln of 7 equals 4, something like this. The e and the ln are not going to cancel each other out. Okay, when they cancel out, ln of e will cancel out because that really equals 1. Because that's the same thing. The ln of e is the same thing as log base e of e, which again equals 1, or in sense cancels each other out. The other situation that things cancel out would be e raised to the natural log. That's when they will cancel out again. Okay, e raised to the natural log. So I hope that addresses those first questions. Now this other one also, can the log only be canceled out when using our change of base equations? Well, log can be canceled out, and we'll show that here. So if you have log base 7 of x, how I want to cancel out the log base 7 is do 7 raised to the power of log base 7 of x. Then I can cancel them out. And so that goes for any kind of base here. If it's base 7, base 8, base 10, base 11. Let's see another one. If it's log base 13 of x, then what I want to do to get rid of log base 13 of x is I got to do 13 raised to the log base 13 of x, and then I can have them cancel out. And so it's all about choosing a base and making this, choosing the correct base and then making this your exponent to get them to cancel out this way. Okay, and I hope that addresses that question there. The last one is for compound interest, what would the number of compounds be when there isn't a value in the question for it? Now, I think I'm under the belief that we have not ran into a question where this is the case. Every single time it should tell us, okay, it compounds quarterly, it compounds monthly, it compounds yearly. All right, it's going to tell us some kind of compound if it's going to be compounded, if it's compound interest. Okay, if it doesn't say, okay, it has this many compounds, I think the assumption is to say then we have compound continuously. And I believe, and I don't know how good my writing is going to be in here, my text writing, but I have the first interest one being A equals P1 plus R over N raised to the N times T. And this is the equation you're given if it's compounded, and you can find some kind of N. So if it says, you know, compounds monthly, that would be 12 compounds, because there's 12 compounds, 12 months in a year. Okay? If it was compounded continuously, if we don't know the number of compounds and we're going to assume that it's compounded continuously, that's when we use a PERT, P-E raised to the R-T. Okay? I hope this addresses your question. I know this one here, the number of compounds. If you have a specific problem where you saw this and you want to share it, then I can maybe address it a little bit more. But I hope the other ones were addressed fully and completely for you.